Assalamualaikum. So in this video, I'm going to present some examples of sensors that are covered in your slides. So the first one is the strain gauge sensor, which is one of the active sensors. So in your slide, you have seen that this is a strain gauge sensor. So the sensor has its own default resistor. So let's call it R. And then if you provide attention, for example, you give this force. So if you give this force in this direction to your sensor, the sensor will experience a tension. So when it experiences tension, it will increase the resistance. So that's why you have the plus sign. But if you compress, means that you have a force underneath. The compression will cause the sensor's resistance to decrease. So it's minus delta R. Okay. Now, it does not generate an electrical signal itself. By passing a current through it, its electrical resistance can be measured by detecting variations in the current or the voltage across it. So based on that, we are going to measure the voltage. This is the construction of the circuit for you to measure the voltage when you have change in the resistance. Okay, so what I want you to focus on is how you get to this equation. Alright, so you have this voltage supply and this is the voltage measured. So your sensor is here. Okay, I want you to focus on the positive sign of your V out. So if your V out has a positive sign on your right, it means that this combination here should be the first term. Okay, and then the one at the numerator is your R4. So R4 over R2 plus R4 minus, okay, minus R3 over R1 plus R3. And then this whole term multiply with your input signal. So the next slide is just showing on the calculation, and approximately you can get this term. Normally delta R is very small, so that's why we can ignore this term and you will end up having delta R over 4R. Okay, so for example in this slide you can see the plus minus sign here. So it means that you have to put this side first in the equation. So you start with the bottom one, R plus delta R over R minus delta R plus R plus delta R. So this is the term here. Okay, and then minus R over 2R over here. Okay, now compression means minus, so that's why you have the minus sign here. And then tension is stretching, so the stretching causes a positive resistance, so that's why you have the plus delta R. So you have to know what happened to the resistance during compression and tension. Okay, so initially I will just put a default value R, but you must know what happened to the resistance when you have these forces. Okay, so the next slide is showing another equation that you can use to calculate what is delta R. So delta R can also be calculated using this equation, where your R0 is the initial resistance, okay, the default resistance, G is the gauge factor, and epsilon is the strain unit deformation. And then epsilon is also equivalent to the mechanical stress over Young modulus. Okay, another way is this equation as well, where your strain deformation can also be calculated using delta L over L0. This is the length of your strain gauge. Okay, so just take note on these three formulas, because sometimes I can give you this kind of information for the strain gauge instead of the circuit.